Okay, so now I'm going to introduce our speaker, Dr. Tim Clarey. He's been with ICR for probably over 10 years now. He's got a degree, a doctorate degree in geology. He's worked in the field on a few different companies, as you see there, including an oil and gas industry. He has taught at universities, and he's published a bunch of papers and books, and some of you can talk to him about that after the fact. And so today he's going to speak on 5 secrets of superfaults. What's a superfault? Well, he's going to talk about it. It has something to do with mountains, but I'll let him explain it. So with that, Tim, come on up.
All right, thank you. Thank you, Heinz. I get a little feedback. A little too much? A little too much? Well, some of this research that I'm going to talk about tonight, I haven't talked about it in about 8 years. So I revamped the whole talk today, and we'll see how it's going to go. But a lot of this research began when I was with the oil company. So I worked the area up there not too far east of Yellowstone National Park, not too far from Cody, Wyoming, if you're familiar with Cody, Wyoming. That's kind of this area. In between Cody and Yellowstone is where a lot of these faults I'll be talking about actually occur. But I'll talk about other faults as well. Back in 1961, when Whitcomb and Morris wrote their book on the Genesis flood, they didn't believe in these thrust faults, like Heart Mountain Fault. And these other faults, they thought they were just out-of-place fossils because there's no evidence really of the movement. Well, there is a little bit of evidence, but it wasn't until the 1970s that geologists started drilling into these rocks all over the American West, particularly Wyoming, Utah, and Idaho. What's called the overthrust belts. Now they started drilling these wells and they're realizing these rocks really did move. But the problem they have is they still can't explain how they moved. Only the flood can explain that, and that's kind of the short story I want to talk about. I'm also going to be speaking, I guess, tomorrow night in CTAC, right? Is that what you call it? Tomorrow afternoon and tomorrow evening. So if you need more information, talk to this young man here. Or you can talk to Benjamin, my events coordinator that came along with me. We refer to him as my handler because he just points me in the right direction and says, get going. And so I work today. And before I forget, I'm going to forget, October 17th and 18th, we're going to be in the Portland area doing an ICR tour with a bunch of our science staff, myself included. And so that'll be this October. Portland's not that far away. We've been there before, I think. So, yeah, it's the first time I've been up here this far. Benjamin and I got to go to North Cascades National Park yesterday a little bit. Good thing it stays daylight so late this time of year. We got to get in there and get out of there. It's really beautiful. I didn't realize there were mountains up here that weren't volcanoes. You know, these reminded me of Wyoming. And so I didn't say in my little story there, but I went to school at Wyoming for my master's. And then I went back later after I worked at the oil company for about almost 9 years. I got laid off because oil prices were so low that they laid a bunch of us off, and I went back for my Ph.D. But that was God's plan. You know, I didn't know at the time that it was His plan for me to get a Ph.D. And that's why ultimately I ended up at ICR with a Ph.D. in geology. And we all try to do research at ICR. You know, we've got 5 full-time scientists who are doing research in different genetics, and we've got our physicist doing different things in astronomy, but he's also working on longevity. He's finding that animals lived a lot longer in the pre-flood world, just like the Bible talks about people lived a lot longer, and they matured slower as well. And we've got our geneticist has been vindicated recently because eight or so years ago, Jeff Tompkins found out that the humans and chimps are only about 84% alike. A lot of people scoffed at that, even some other creationists. But just about a month ago, the secular community realized that sure enough, it is 84% or thereabouts, so within 1% or 2. So he was right all along. He was one of the first to actually discover that, and everybody kind of doubted it, but it's kind of nice to be vindicated. And our most recent research we're doing right now is the cavefish, blind cavefish research. We're working on what's called the new theory of biological design, where we think the animals themselves were designed by Jesus, our creator, to adapt to changing environments. And so they have within their DNA, they can shut off switches, and they're the same species, the blind cavefish and the fish that are outside the cave. They're not cavefish, but they have eyes because they're outside the cave, and they're the exact same species. And they can interbreed and everything else. So we're trying to experiment and see if we can actually bring back their eyes within a couple of generations. And so we have a really good lab going. It's been going on for a couple of years now, and that's kind of really exciting. So we're trying to put the R in ICR. You know, we do try to put a lot of research in And my research is all about the flood. I've been gathering data across the world. I've gathered 6 continents worth of geological data from oil wells, offshore, onshore, everywhere else. And I'll be talking about that tomorrow. And a little bit tonight. I'll throw a little of that in for you guys. But this talk mostly was an outcome of some research I started back in 1990. I published my first paper. I was with the oil company. Still, and this came out on this fault in Wyoming. It's a really odd fault that nobody hears much about, but they hear about Heart Mountain, the Heart Mountain fault. He goes, who's heard of the Heart Mountain fault? So if you read Henry Morris's book, he talks about it in there a little bit. But I think they really are real. Yeah, but only the flood can explain it. Ultimately, that's what we're going to find out. But there's 2 ways to view everything in geology. There's the old Earth model, which we're all taught in the public schools and the secular colleges we went to, where everything takes millions of years, just like those whales took millions of years to evolve, but yet there's no real evidence that they did. And many of those fossils, of course, don't even exist as whales. They're just land animals. But that's the idea that millions of years to deposit all the sediments and all the fossils we have, et cetera. And there's the young Earth model, which when you read the Bible, that's the only conclusion you can come to. That's why those genealogies are in there, that everything happened much quicker under the right conditions. And there was this year-long flood, a global flood, not just a local flood, that really deposited all the sediments pretty much we see, maybe not all, but most of them, and most of the fossils that we see, and a few more right on top after the Ice Age or during the Ice Age. But this is what's going on today, and this is why evolutionists believe the Earth took millions of years to separate the continents from this Pangea. So at ICR, we do hold to a type of Pangea that separated as the flood was progressing along. But today, the rates are only a couple centimeters per year. See that big line over there? This shows 10 centimeters. So some of the Pacific Ocean may be moving 12 centimeters per year. You're looking at this much or this much per year. Well, John Baumgartner modeled this back in the 1980s with a government supercomputer, and he showed that when you start to subduct plates into the Earth, they're going to go through runaway subduction, he called it, where you're going to have stuff moving this much per second. This much per year versus this much per second. So today they're moving very slow. And the reason for that is all the original crust got consumed and now everything's kind of hot. And hot things don't like to sink. Just like hot air balloons like to rise, well, the crust was recreated, as we'll see. But that's not the point of my whole talk. But he has been vindicated as well. His models have shown. So he says these things are dropping in fast. You guys are living on the edge of a subduction zone here. You're all living on the edge. Chance for a big earthquake because you're in a subduction zone. This is where the biggest, deepest earthquakes occur. If you get a shallow one, they're really bad, and they can actually move the water offshore and create a tsunami as well. So the area off Seattle, you guys are living on the old Juan de Fuca plate that's being subducted underneath North America. But today, it's only moving this much per year. And so, but there will be an earthquake sometime down the line. It's just a matter of when and how big. But hopefully, not tonight. But we'll see. But it could. And people are going to wonder, well, how can that happen? Well, you're in a subduction zone. But there's magma coming up here. It's making the plate bigger. That plate's very small here, and you see the Cascades, of course. That's like Mount St. Helens erupts occasionally. During the flood, of course, there was a lot more activity, everything moving faster, more volcanoes. Everything goes speeded up. And there's actually evidence that this did actually happen. If you see the geology that's been published the last 20 years, they're using what's called seismic tomography. They're actually visualizing in the Earth these blue slabs that go down. Well, those blue slabs are the same density that we see at the surface. So these deep blue slabs go all the way down to the top of the core. 1,800 miles down, some of these. All the way to the top of the core, and they're still cold. How can they be the same density, which implies the same temperature all the way down? This is exactly what John Baumgartner predicted. We had this runaway subduction with his models, and now the data is coming in where it looks like a cooked spaghetti noodle down there. But it's still the same colors because it's the same temperature. So evolutionary scientists have found these really cold blobs sitting on top of the mantle, and they're like scratching their heads going, how can this be? Well, if you believe in a year-long flood where you had runaway subduction and a real rapid plate movement separating the continents in the course of a year, making a whole new seafloor, that's what you get. So John Baumgartner's model was correct. Well, part of the problem, when you start moving things, you get a lot of massive movements. So tonight we're talking about superfaults, and that's really what happens. New discoveries are out there in the last 20 years as well about these faults. And many of them, not only are they called overthrust faults, some of them, but there's also other faults, subduction zone faults that move fast. They demonstrate current movement rates have not always operated at slow rates like we see, like they predict in the past. Superfaults are not discussed in most textbooks. You can pick up your geology textbook. They won't even have the word in it usually. If you look through the literature, do a Google search, you'll find superfaults out there. There's a little bit of discussion. So we're going to go through 5 secrets of these. And again, this is one of my more sciencey talks, so those of you that, if you don't like science, you're going to get a mouthful tonight. But there's a good ending to it all. God has a plan. Superfaults move extremely fast. That's one thing you can remember. Superfaults have global extent. We find them all over the world, every continent pretty much, maybe not Africa, but most every continent has superfaults of some sort. Third, superfaults move by the force of gravity. And so these rocks are not pushed. All my college textbooks talk about pushing rocks. You can't push rock, it just crumbles where you push. And you try to do that, get a big piston to push rock, it's just going to crumble where you push, as we'll see. Four, superfaults move with the aid of high fluid pressure. Just like you can glide on ice with your ice skates, because it melts right into your ice skate, that's why it's so small. You can glide around on it like water between 2 plexiglass sheets. You can get that to slide really, really easily. So you got to get these kind of conditions. And fifth and finally, superfaults can occur only under the conditions of the global flood. That's my argument. The only way we can explain these movements that we see the results. See, in geology, we see it's forensic science. We see the crime scene, but we don't know how it got there. We see the dead animals, we see the fossils, we see the sedimentary layers, we see the evidence of these big, massive faults that took place, but yet we don't know how they got there. And the only way I argue for superfaults with massive amount of movement is the flood, because they gave us the right conditions. So let's look at number 1, superfaults move extremely fast. Here's the definition. I don't know if you want to write this down or not. You don't have to. There'll be no quiz later. Should we do a quiz later? You guys are getting worried. Quick. Definition of superfault, it's an unconstrained single slip event, meaning it just moved once, that moved at a velocity greater than 4 inches per second, so greater than about that much per second, which is pretty fast if you're a geology person, because they think everything moves really slow. But you've got something that far per second and move more than 300 feet, or 100 meters or thereabout. So that's really what it is if you look up the definition. I don't know what AI will say now when you Google search, everything comes up AI, but that's how it was defined 20, 30 years ago. But still, people don't recognize these much. Superfaults are at odds with uniformitarianism. That's the problem. So they don't talk about it much because it shows things move fast in the past. They don't like to talk about catastrophic events like the Missoula flood. They don't like to talk about it. It took poor J. Harlan Bretz like 40 years to convince anybody that he was onto something, to explain that as a catastrophic flood, because catastrophes and uniformitarianism don't get along. So these are catastrophes. So what do we see? We see faults like the Hart Mountain fault. And this is Hart Mountain. If you've been to Cody, Wyoming, you probably saw this in the backdrop. Anybody been out there to see Hart Mountain? This puts a bunch of younger rocks. Actually, it puts what's called Eocene rocks, which are part of the Cenozoic, which I believe is the receding phase of the flood. Puts those rocks on top of, actually, no, I got that wrong. The Eocene's the bottom out here. It puts these early flood rocks on top of the Eocene rocks. So this is something that happened late in the flood after some of the receding phase was already occurring. All of a sudden there was this big massive movement. And so it placed older sediments on younger, moved up at a 1 to 2 degree slope. I kind of exaggerated there a little bit. But again, if you have the right fluid pressure, this can happen, as we're going to see. So the Hart Mountain fault, which again Henry Morris wrote about in his Genesis flood book. At the time, they didn't know how these faults worked. They hadn't drilled enough oil wells into them to see that they're real things, but they really are real. It moved about 25 to 35 miles. It covers an area about 1,400 square miles in area, and it's made out of limestone or carbonate blocks. So these big limestone sedimentary rocks deposited early in the flood, broke free and slid down this massive 1 to 2 degree slope, which even the evolutionary geologists kind of like, yeah, that couldn't have happened. But enough of them actually saw the data and they realized it did happen. And it occurred in what's called the Middle Eocene, or what they call the late flood. In terms of my megasequence research, this would be the Tejas megasequence, if you're familiar with that. Well, how to do this? Well, there's still some debate, but the latest story says that somehow the zone that it slid on turned into CO2, supercritical CO2. Under real high temperatures, 800 degrees Celsius or so, you can actually dissolve the dolomite or the limestone with a little magnesium mixed in there, and it actually caused the detachment. So you have a liquid layer that forms in between these two layers. And so if you, just like water between 2 plexiglass sheets, and you squirt it in like you used to have my students do, you can get the top sheet just to take off. So if you ever had a glass that's condensing and it's on a little bit of a slope and all of a sudden it starts sliding, that's exactly what happened. How do you maintain that water pressure over millions of years? You can't. So these things had to move fast. So we'll come back to that later. Do you guys ever do that? You have a glass that slides on a table? It's the same experiment that geologists did in 1959. But they still can't believe it. So here we have velocities. This is published. I didn't make this up. This is published. One paper said that the velocity of the Heart Mountain slide must have been about 90 miles an hour. So this is one of the biggest and largest landslides that ever occurred. Fortunately, Noah was still on the ark. So were the 8 people and all the animals. So this is the receding phase of the flood. The volcanoes at Yellowstone were erupting during the receding phase of the flood. And this was a consequence. A lot of the volcanics actually piled on top of this and covered a lot of it up. That's why it's been so much fun to study this as a geologist, because you're only seeing little bits and pieces. You know, it's like you got the bread on top of your sandwich, you can't see what's in it. You know, you don't know what you're eating until you can see the edges of it. Is it all peanut butter and jelly? Or is there something else on the other side? So it's difficult to see when you can only see around it where the rivers cut through it. But that's what they've estimated coming up with. And this is kind of how it works. Here's the Heart Mountain Fault, how it broke and slid like that, 90 miles an hour. And those are some of the carbonate pieces we can still see across the area. And then there's the South Fork Fault, which I worked on, which happens down here. And then you cover everything with volcanics. So most of this was all covered over. And you can't see a lot of it. But you can piece enough of it together. And I spent, I don't want to tell you how many years of my life working on this, off and on. You know, a few weeks, I took a 20-year hiatus, and I went back out and did a bunch of mapping. And I cut all those pictures out where I went out by horseback, because the only way to get into the wilderness area and go for many miles in the wilderness area is really by horseback to collect rocks and come back. You can't ride a motorized vehicle. And so I had to go up to these cliffs up near Cody, Wyoming, up in this area, in this region up in here, and go back and see where did this thing break away and slide. And so I got a chance to look at all these things in firsthand. So let me do that again. Maybe we'll go back and we can watch that. You gotta watch fast because it moves 90 miles an hour. See, there it went. There's the Heart Mountain Fault, and now the South Fork Fault's going to break down here and slide away. So one went, and then the next one went. We'll talk about both of those a little bit. And then the volcanics come on top in red, kind of covered most of it up. So we only see little glimpses of it here and there sticking out behind all that covering, kind of like you threw a blanket on it. So there's the Heart Mountains out here. That's that little piece I showed you earlier, sticking up. That's the one remnant that went out there. There's a few more even out here. This is Cody's over here. That's the Buffalo Bill Reservoir. The road to Yellowstone goes through here. You've been to Yellowstone? Anybody been to Yellowstone? Did you drive from Cody to Yellowstone? You drove along that. You just went by the reservoir. It's kind of cool. Well, many superfaults also generate melt, which we call pseudo-tacholite. So pseudo means not real, not the real thing. Tacholite's a volcanic rock. And so this is called pseudo-tacholite. I don't know, it's not the best name. I didn't name it. But, the guy that named it that, you know, so I just call it PST for short, because it's hard to spell. A lot of Y's. It's a frictional melt. So you can, faults that, you know, move, they generally don't melt the rock, but if they move far enough and fast enough, like superfaults do, then you can melt the rock. And so you get little thin melt zones here and there. Hope that's not my phone. All right, because I get in trouble from you guys if that happens. So it's frictional melt with temperatures approaching 1,200 degrees enough to melt the rock. And that doesn't happen very often unless you have a really fast movement along these faults. The San Andreas Fault's not melting when it moves. It moves and jerks and moves and causes big earthquakes, but it's normally not melting the rock. But there's a lot of melted rock out there if you know where to look. And they're usually very thin. So this confirms rapid catastrophic superfaulting when you find pseudo-tacholite. Well, I got a chance to go up to Kodiak Island. Even before I worked for ICR, they funded me to go up there as part of their FAST research project, which stood for, I forgot what it stood for. It's a big acronym. FAST something, sedimentation and tectonics, fault activity, I forget what it was now. But anyway, John Whitmore and I, a few of us others, were all getting money to do different research, and I was researching this fault that I let sit for 20 years in my head stewing, going, how does this thing work? Because I would look at the toe of the slide, but not where it broke away from. So the subduction zone during the flood is what the Pasag Shack thrust was on the edge of the Kodiak Peninsula. So if you look where Kodiak Island is, it's kind of there. And there's another subduction zone just like we have here, but here it's oceanic. It's ocean crust against ocean crust, so you're making a volcanic arc the volcanoes don't come through the continent like the Cascades, like Mount Hood or Mount St. Helens, they come through the ocean. So you get these islands just like you see all around the Pacific, that whole ring of fire, the Philippines, all those islands, the Aleutians, they're all volcanoes that erupted as the floodwaters were receding, I believe. Most of these are pretty young, but they're all erupting all at the same time, which helped bring on the Ice Age, and that's another story. But here you have this area where you had an ancient subduction zone that's no longer subducting, and this is what it looked like up there. It's really pretty. I did see whales out there swimming around one day. I didn't see any legs on them, though. I was watching them like, nope, no legs, just a big tail. And then the puffins are flying around up here, and I had to slide down this hill, almost literally. And then we had to get out of there because the tides are so big in this area that they come in about 15 feet high or more. So my guide I was with was worried one day I wasn't going to make it out because we had to get to a certain spot of the hill where you could climb up it to get out of there. But we had a good time for about 3 or 4 days collecting rocks. And here he is, and this guy, here's my guide. His name is Michael Phelps. It really is. He's not the Michael Phelps, but he was Michael Phelps nonetheless. But here you can see the pseudotactylite, those little black areas. That's the rocks that got so high. Everything else was cooking in here, making metamorphic rocks. But these areas right here are moving so fast that they melted. And there's no melt this thick in the whole world, other than right here so far. Usually the pseudotactylite's like this thick, and people can barely see it. And even that is a super amount of movement. But the geologists who studied this said we won't even guess how much movement this must have created to make that much of a fault. So here is a subduction zone. I talked about those cold slabs deep in the earth verifying subduction. Well, these are the rocks that verify subduction was moving along really fast, so fast it was causing this much melt, which is beyond what they even will estimate. So what they said in their literature is extraordinarily large, great amounts of slip. So to get 1 inch requires 30 feet of slip, they think, and then so to get 12 inches like we see, you had to have 360 feet of almost instant slide within a second. So this stuff is moving along 360 feet or so per second, which is pretty fast. That's a subduction zone. So there really was runaway subduction. There's rock evidence, and there's seismic tomography evidence in the earth that these slabs went down there so fast they didn't have time to heat up. Because it's a lot hotter in the earth, 3,000 degrees hotter than at the surface or more. As you go to the core, we think it's about 5,000 degrees. But just on top of the core, you're looking at probably 3,500 degrees or more. And so how can those things still be cold that deep unless they went down fast? And here's rock evidence to prove it. So Heart Mountain is moving close to 90 miles an hour. Kodiak Island, you're moving stuff 360 feet per second, which is faster than 90 miles an hour. You can't drive your car that fast. Now, if you have a rocket, you can, but that's another matter. But that's extremely fast. So how does that happen? If you believe in uniformitarianism, these things should move along really slowly, like an inch per 1,000 years, an inch per 100 years. Something ridiculous, but that's not the case. So let's move on to our second part. Now, the superfaults move fast, but they have global extent. It isn't just at Kodiak Island, it isn't just here in Wyoming, it's all over the world. So where do they occur? Everywhere there's a subduction zone. So again, this is a subduction zone over here. I feel like I'm working through the shrubberies, sneaking up on it, but there it is right there. So here's you guys, you're back here, you're kind of hanging out here, and then you got your volcanoes, Mount Hood, everything else, and then you got some faults going this way because this is going down and stuff pushes up. So you get some here, and you get a lot of them over here in what's called the fold thrust belt. And you see these in the Andes, you see these in Europe, the Alps. All these things are these faults that moved a lot of sediment. So they're active here and they're active over here. And they're all over the world. So here's in red are the subduction zones with overthrust. They're coming right through the middle of the continents over here, around here, Andes, the Rockies, all the way up through the Alaska, all over, everywhere there's subduction around the Pacific as well. So the whole ring of fire goes all the way around the Pacific. You see these subduction zones. You also see these superfaults that occur. And what we have in these areas, they call it thin skin thrusting. So it doesn't affect the entire crust of the earth. It only covers the sedimentary rocks for the most part. So you leave some rocks undeformed below, and you're kind of pushing just part of them. You're kind of delaminating. So geologists call that thin skin thrusting versus faults that move from the basement all the way up, like to make the Colorado Rockies and what you guys have around here in the North Cascades. You have the basement all the way to the surface. Well, here you would leave the basement down there, and you're just moving some of the sediments. But it's got to break free in a layer that has to have a high fluid pressure. That's what we're finding out. Here's in Wyoming where I work for Chevron, where I work in the overthrust belt. We're drilling all these wells in here, and you can actually see all these thrusts stacked on top of each other. You know, the basement's not even moving out here. The crystalline basement's down here with this pattern down here, and everything's sliding on top of it. So they're breaking free and cutting up, and the next one. And they basically get younger as you go that way. And so the older ones deform the other ones, and so you get all these rocks. They're very, very complicated geometries, and it's very difficult to draw these sections. But the oil wells kind of really pin it down. So you can see the oil wells over here, oil wells through here, and the seismic data helps a little bit as well. Well, those are pretty common. You go to Montana, you see the Lewis overthrust. Same sort of thing, pushing really old rocks on top of younger rocks. And you can see all these thrusts stacking. You go to Canada, the Canadian Rockies, they're just full of these. That's what you see, these big sedimentary units pushed up, and they were folded up from the one that moved before it. So the one behind it kind of piggybacked and got pushed up. So they look like they're going really steep because the next fault in front of it lifted it up and kept lifting it up. So it's like you kept stepping on the mud and it kept pushing further and further out. And these things slid down very, very gentle slopes. But you're seeing the toes of them where they stick up because they can't keep diving down. They have to dive up to the surface because that's easier to push things to the surface. There's nothing there to push against you. So here's Chief Mountain in Montana. We're almost on the Canadian border, eh? So I can speak Canadian because I'm from Michigan. I have Canadian relatives in Nova Scotia. I've been to Canada a lot, looking at a lot of cool rocks in Canada. And they do say "eh" a lot in Ontario. As soon as the guards, you know, the border, like, well, where are you staying, eh? Where are you, how long are you going to be here, eh? And then my students would start laughing. I'm like, stop laughing. You're going to get us all pulled out. When they'd pull us all out. But anyway, these are rocks. These are really, really old, early flood rocks. Some of these are called Precambrian even. But those are limestones, again, just like Hart Mountain. Limestones on top of, in this case, higher flood level rocks, the Cretaceous. Not the end of the flood. So here's Mike Ord for scale in blue. You guys know Mike Ord? Yeah. We went up there, we hiked up there. There's his arm, and there's his little Mike Ord body. And I forget who was there with us, but there's the fault. And you can see these are all limestones, and there's the boundary between them. There's almost no deformation. Just like Hart Mountain, there's almost no deformation. And I've been to Hart Mountain. I cut that slide to save you some time tonight. We'll be here all night if I showed all my pictures. It's like, to a geologist, pictures of rocks are like vacation photos. It's like, I could show you rocks all night, but this was kind of fun. So we took some samples of there and did some work on it. But the bottom line is, thrust faults or superfaults that made them cover, you know, a big part of the world. And actually, 80% of the world's mountains are very, very young. They all formed when the water was receding. So the Rockies and most of these things were forming, these superfaults were forming, these thrust faults, these overthrusts were all forming as the rocks were receding. So these are all flood rocks, flood sediments that weren't rock yet. They were able to be moved and slid down slopes. They didn't get pushed. They slid down very gentle slopes, just 1 or 2 degrees. To do it, you got to have moved by the force of gravity. So 50 years ago, geologists believed these things moved by gravity. They didn't understand it very well, but the few they were understanding, they said this has got to be a gravity slide, just like a landslide. You see the landslide comes down, it breaks free, slides down, and there's the toe of the slide. You guys ever see them on the side of the hills? Get a lot of rock slides around here, but do you actually see landslides? Sometimes the overpasses, the people build in Texas, the rocks will slide away. They don't have it packed down well enough. But gravity is a great force. It operates equally on that entire landslide at the same time. So the overthrusts are difficult to explain mechanically. So you study these in your geology, structural geology class, and everybody goes through and they talk in circles a lot and say, well, we think it works like this, and we know they're millions of years old, so it must be working like this. And so they figured out the geometry and the rules of overthrust back in the 70s, and they started drilling all these things again after Henry Morris wrote his book. And he was right to scoff at it at the time because nobody knew any better. But now we realize these things are real, but they still can't explain the mechanical difficulty in moving them. How do you move big slabs of rock? These slabs are sometimes a mile thick, and they move for hundreds of square miles all at once. And the evolutionary guys say, well, that moves slowly over millions of years. You know, how do you maintain fluid pressure that long? There's a lot of problems. They talk about this in the books. This came out of a textbook. It's called Critical Taper, or the wedge theory, where they try to argue these thrust faults that you see above can form by a snowplow. You guys have snowplows? See how those work? but you're not pushing rock. You're not pushing solid rock, you're pushing snow, or you're pushing sediment, you're pushing sand, something loose. So it'll work if you're pushing soft sediment. They've studied all these in the laboratories using soft sediments. And they're like, look, we can get these cool features. If it gets really thick on one end, it can kind of slide to the other end. But it doesn't work. Cliff Ollier and Colin Payne wrote this. They're a couple of Australian, I believe, geomorphologists. They study the land surface. It cannot be overstressed. It's not possible to fold rocks by lateral push. Gravity applies a body force in every grain, every molecule in the rock mass. So to move something, to move the entire mass, you've got to have gravity. You can't just push it because you only push it to one end. Here's what gravity slides look like offshore. I studied these offshore Louisiana and in the Gulf of America. That's what it's called, I think, isn't it? The Gulf of America. And some people, the former Gulf of Mexico, actually published a paper on that recently in the Journal of Creation. So the Gulf of America, formerly the Gulf of Mexico. So if the name goes back, it will be covered. But here's 5 kilometers of distance. These things are huge. They're sliding down because you go away from the continent, everything's going downhill. But it's not really steep, but they're still sliding, making these really cool folds and faults, and just like you see in the overthrust belt. So gravity slides really do work. And they know it, and they studied these for years. And again, 50 years ago, people would have said the Alps were formed by gravity, which they did. Now they're going, oh no, it's from tectonic plates moving around. But rocks cannot be pushed, because if you push, they're going to just break where you push it at. The rest of the rock's not going to move. So only gravity can move thin-skin thrusts. And they have to be soft sediments still. So we'll talk about this a little more in detail. So here's what geologists did back in 1959. They figured out if you have fluid pressures, you can move it. Just like your glass of water or your can of pop, as we say in the Great White North. You guys call it pop out here? The Texans, they don't know what that is. I'm like, it's pop. But some of you call it soda, or most people in Louisiana just call it a Coke. They say, what kind of Coke do you want? I'm like, well, I'll have a Diet Coke. It gets a little confusing. But anyway, here's Hubbard and Ruby. This is a diagram by these two guys in the 50s. Actually, it was so-called, it's the beer can experiment. They actually had a beer can, where the beer can started sliding away because they were drinking as they were doing this one late night, apparently. And so they actually got it to slide down here in D. You can kind of see how it slid around. And they did it really flat if you had the right fluid pressure underneath. So if it condensed, you got condensation. Look at that, it just took right off on its own. Very, very gentle slopes. So they realized this back in 1959, that if you get water between rock layers or between sediments layers and get it packed in there, you can get stuff just like water between 2 plexiglass sheets. That's all you need. So if you squeeze something like a sponge of water, the fluid's going to escape, but if you trap it over a big area, then the whole thing will slide. And you can't trap it for millions of years because it'll escape up the sides. So the mechanical paradox remains, the uniformitarian idea remains a big mechanical problem. You have high fluid pressures, gravity slides can move large thrust sheets on nearly flat slopes if water becomes trapped. But their problem is they're in white. High fluid pressures can't be sustained for thousands or even millions of years. So they try to move these thrust sheets slowly over millions of years. And I worked with oil companies. They're like, oh yeah, these rocks move. It took 10 million years for this to move over here and this to do this. And how do you maintain the fluid pressure? Fluid's going to escape. You can't maintain super high fluid. And we're talking super high fluid pressure, not just normal groundwater. So let's go back a little bit to the South Fork Fault. This is the one I studied the most myself, which overlaps with the Heart Mountain Fault. And this is about 4,000 feet of rock that moved, actually at the time it was sediment. And it pushed this Jurassic layers, earlier flood rocks on top of late flood rocks. It moved about 3 to 6 miles, depending where you were, down a 3 to 5 degree slope. So this was ridiculously steep. 3 to 5 degrees. Woo-hoo! 4,000 feet of rock, almost a mile thick. How do you do that? And so the detachment was in the gypsum layer. So you have water trapped in gypsum as it dehydrates and becomes anhydrite. They call it gypsum is what you have your drywall made out of. To dry that out, you got to squeeze the water out of it. So loading sediments on top real fast during the flood can squeeze the water down. It can't get out of that zone, so it gets trapped in there a little bit. And this occurred again, what's called the late flood. If you want to get technical, it's the Middle Eocene, but it's in that Cenozoic or the Tejas megasequence. So most of this, what I talked about in Yellowstone, was all happening as the flood waters were receding. So here's the Heart Mountain system we looked at earlier in yellow. And then there's the South Fork system we looked at earlier that overlapped a little bit right into here. So some of these rocks right here, these things moved twice. So they moved once, and then they moved again when this whole system moved 6 more miles. That moved about 20, 30 miles, and then this one moved a few more miles. But it was the weight of that first one that kind of loaded up the second one, I think, and got the move. So here's a cross-section where you can see the fault system. Here's the Jurassic sandstone sitting on top of Cretaceous rocks. So these are, supposedly separated by 50 million years of time or something like that. And then you've got this detachment. Look how thin it is, just a little zone. I looked at in thin section, you can see there's gypsum in there and quartz and fossils and things like that stuck in there, but there's a lot of gypsum. So what happens is you have dehydration of gypsum, which releases a lot of water. And that water was trapped in there, and it couldn't get out, and then you just have a big footstep on it. Like you're stepping on wet mud, and the whole thing gives. So the Heart Mountain Fault moved, 90 miles an hour, splat, big, thick sheets, 1,400-foot thick hit, and that caused just like stepping on wet mud, and that's going to slide away from underneath it. So you have these boom, boom, one right after the other. So you have dehydration caused by the weighting, tectonically loaded by the weight of the Heart Mountain Fault system, and there's what you have again, so we can watch that again. There it breaks away, and the South Fork Fault breaks away. You'll see here in a second, and there it slid away. Didn't move as far, but it moved those rocks twice, and then it gets buried again. Let's go back, and you can see it get moved twice. So the first rocks down here are going to move twice, these rocks. They're going to move again. So they stopped there, then some of those moved again. So I put this in a big 25-page paper about the time I quit teaching college and went to ICR. And I wrote a paper on this at the ICC in 2013. You can look up as well, which kind of explains a lot of this. But these cool graphics are provided by the media people at ICR. So it's kind of cool. They do a good job. It gave me tears almost when I saw that. Because all these years I could see it in my head. I can 3D visualize pretty well. It helps to be able to do that as a geologist. And my wife struggles with that. She goes, I hated topographic contours because I could never get it. But, it really helps to be a geologist if you can kind of think in 3D. And so I could see it. Oh, she's smarter than I am. Don't let her kid you. I need her. Anyway, but she can't visualize stuff in 3D as well as I can, but she does everything else better. I was in Hawaii one time. I'm like, man, I can't believe how smart you are. She's like, well, you didn't think I was? I said, no, I did, but it's embarrassing how smarter you are. So don't get the wrong impression. She's just modest. Overthrust cannot move without overpressured zones. You got to have overpressured water, overpressured fluid. Somehow you got to either have dolomite dissolving at real high temperatures so it can flow down this supercritical CO2, or you got to have water trapped between layers like in the gypsum layer, or sometimes you get salt layers that trap it. Sometimes you get between shales that traps it. All these ways you need some sort of a trapping to trap water in a very thin zone. And these rocks can slide for literally hundreds of miles. These hundreds of square miles, maybe 10 miles, 20 miles at a time, very, very quickly. That's the requirement you need. So the flood provides the best explanation, I think, for all these overthrusts. The evolutionary community can't explain the mechanical issues they still have. They see the results. They see these overthrusts. They drill into them. They know they're there. They know they're real. But they have no good way to explain how they got there in their old deep time paradigm, because these things had to go fast. And there's a few of them that realized the Heart Mountain moved fast. And when I published my paper on the South Fork Fault, I said the South Fork Fault moved fast. And most people agreed with me. But they don't realize the implications. Is that, all the faults out there, all these faults had to move fast because they can't maintain that high fluid pressure for millions of years, like they try to argue. And you can't push rock. Ask any engineer, you can't push rock. It's just going to crush where you push it at, and the rest of it's not going to move. It's just going to buckle and go. So you need a little bit of tilting, which I think the flood provided. There was a lot of heaving going on during the runaway subduction. John Baumgartner modeled that the crust of the earth actually rose near these subduction zones, so where you're at would have rose a little higher. By the way, you're living on land that didn't even exist before the flood. You guys are living on what they call these, pieces of probably was out in the pre-flood ocean that got smeared on, accreted on, they call it, the real word is accretion, onto the west coast. So everywhere between here and California, Washington, Oregon, British Columbia, a lot of it didn't exist in the pre-flood world. You guys are living in, metamorphic, squeezed and cooked and crushed rocks that got pushed this way, and then you got volcanoes coming up through it all, making your Mount Hoods and your Mount St. Helens. But you guys are living on, young continent, so to speak, compared to most people. The rest of the world, has got another 1,600 years on you. Because, the flood was 4,500 years ago, thereabout, and between the creation of the flood was about 1,600 years. And then they added all these things. So you're part of that runaway subduction process where all the debris and dirt, like pulling the rug out from underneath you, everything out there just kind of got stuck onto you guys and became California, Washington, and Oregon. And so I'd say, if you get over to Spokane, you're on the original crust. Over that way. So how many of you knew that? Some of you were nodding. You're like, oh yeah, I heard about that. So there's suspect terrains, they're called. They don't know where you came from. But, you guys are very suspect people. So you become like the geology you live in. I'm convinced. That worked in California, I used to say. It's, you get a little bit, all these different terrains came in, got all messed up, and it doesn't work up here in Washington so well. You guys are too serious. My attempts at humor. But anyway, Texans are pretty boring for the most part because they're a stable part of the country. Michigan, where I grew up, is pretty boring. Stable part of the country. But the coastal areas are the very active areas that got really affected, or the plates were moving around. And so that's why the liberals seem to be attracted to those areas, I think. Because you become like the geology you live in for some reason. Folding while sediments are unlithified. That's the other key. You can't fold rocks unless they're still packed down sediment. You can't fold rocks either because they'll crush into a bazillion pieces. You won't find that number in any book, but that's the number, a bazillion. You can't fold it. And so the old Earth scenario says this, deformation long after deposition, these faults, if there were superfaults, they moved long after these became rock, and they should have been very brittle. The young Earth scenario says they're deformation soon after deposition. They were still soft when deformed. And so again, it's impossible now to push rock, because this is what's going to happen. You're going to just deform it at the end. And then if you run into something, it's the same thing. You get squished on both sides. It's very brittle. But what do we see? We see folds like this. See those big chevron folds, those big V's? Those things were like an accordion because they were still soft. These are some of those thin-skin thrusts in Montana, the overthrust belt through Montana, slid up and down. Here's in Grand Canyon, there's some Tapete sandstone you guys probably hear about. Andrew Snelling published some really good papers on that in his Answers Research Journal. Anybody read those? Of course not. They're 50,000 words long. I had to review them. 6 of them. 6 50,000-word papers. Nobody writes longer papers than my good friend Andrew Snelling. But anyway, he talked about these folded rocks. How do you fold these rocks? And he showed the evidence in thin sections. There's no evidence of deformation. These things just slid because they were still wet. And there's a person for scale, a few people down there. But these big folds, how do you fold rocks unless they're still soft? And you can go on and on. I could show examples again until midnight, but I didn't because you guys want to get out of here sooner or later. So there's 5 secrets to superfaults. Really, so number 1, superfaults have to move very fast by definition. They have global extent because we see them all over the world in all these thrust belts. Superfaults move by the force of gravity. It's the only force that can move a whole sheet of rock or a whole sheet of sediment at the time. And then 4 superfaults move with the aid of high fluid pressure. You got to have them kind of floating along. So the fluid pressure is so powerful that it actually makes the rock above it or the sediment above it weightless. So water is, very incompressible. It can do that. So you get under high enough pressure. But it's not going to maintain that pressure very long. So if you're an evolutionary geologist in here, I want you to explain that to me. How can you maintain that fluid pressure and move those big thrust sheets over millions of years? That's what's being taught in the schools. That's what they tell you at the oil companies. They also tell you oil is 150 million years old. That's another story. Can't do that either. But just because you find it doesn't mean you're right. You're finding oil and finding these structures because they moved there fast just thousands of years ago. You find oil because it only formed in the last few thousand years, or it'd be all eaten up by bacteria. So superfaults, the last point, can only occur in the Great Flood. So let's talk about the Great Flood. Did God say there was a great flood that covered the earth? Of course he did. He says it in 2 Peter 3. It's not just in the Old Testament. He talks about a global flood. But a lot of people like to say, well, it's just the world of the time. Who's heard that one? See, we all hear that. It's just the Mediterranean or the Middle East. Well, why did you bring birds on the ark? Why does God say, birds will be brought to the ark? God brought the animals to the ark. God shut the door on the ark. Why would you bring birds? The birds could have just flown away. Noah and his family could have left. It took them 80 or 100 years to build the ark. They could have just gone somewhere in the country. They could have gone to Mongolia and have been safe. But no, there was nowhere to hide. There was nowhere to go. Everything in the Bible, biblically, implies a global flood. The world that then was overflowed, the water perished. Not just a local world, because why bring the birds? So, was it local? No. Geologically, it's not local either. The research I've been doing the last 12 years since I joined ICR has been to compile columns all across around the world, oil and gas columns, stratigraphic columns, and every uplift, every major uplift, every country of the world, every mountainside, anywhere they measured the rocks, and the oil wells measured the rocks. So if you drilled a well right here all the way down to the crust, which I don't think you have to go very deep here, because you're in North Cascade, you're there, you're on the crust. Whatever sediments are there, I plotted all this up on this database. And it's taken years and years and years to do it. And no one else has done this, to my knowledge, in the world in the last 50 years or so. There's people that have estimated stuff, but there's so much more data now offshore where they're drilling in 15,000 feet of water way out there. And there's data off Brazil and off the deep Gulf, finding this huge whopper sand out there in the Gulf that shouldn't be there. 200 miles offshore, it's over 1,000 foot thick. And I also found that there's no crater at the Chicxulub impact site. There's hardly any melted rock. And there's no crater, it's just a gravity signal. That's hocus pocus. That's another story too. But anyway, these columns tell you what's really there, what's still there today. After all the erosion and uplift at the end of the flood, when the mountains were all rising, 80% of them all at once, all the erosion took off and washed everything offshore. This is still what's there today. And I kept track of about 16 different rock types. And there's a lot more rock types than that, but you can kind of generalize them into these 16 groups. And I kept track of these 6 megasequences, these big chapters of the flood. So in Cambrian Ordovician, we call that the Sauk megasequence, which you guys have the Sauk Reservation right here. Well, didn't the Sauk get transferred from Wisconsin to here? Isn't that what happened when we were displacing the native tribes and moving them around? I think that might be the case. But that's the first megasequence down at the bottom is the Sauk. And in my home state of Michigan, this is one of the Michigan Basin, it's at the bottom down there. Then you get the Tippecanoe and Kaskaskia and then Absaroka and a little bit of Zuni, and then you don't get the receding phase. It's all eroded off. So a lot of erosion that took place. And some of these, like Grand Canyon only has about 4 of these. So you don't have the whole record there anymore either. Every continent has the same patterns, as you'll see. That's what I found out looking at all 6 continents. So this wasn't just something I did in a weekend. It's a lot of data mining, a lot of papers to find, a lot of oil well data to find, on and on and on. But not to brag, God's one that allowed me to do this. God's one that gave me the wisdom to do this and the inkling, the background to do this by working in oil and gas and then bouncing me around. When I came to ICR, I was 52 years old. I finally realized that's God's plan, was for me to work on this project and show people there really was a global flood. I'll be talking in more detail about this tomorrow night. But it shows that every continent has the same order of rocks. There's places on the continents you can find all 6 megasequences. In the Williston Basin here in North Dakota, in Syria, in the Tarim Basin, I think in China, however they say it. They're just a little bit thicker in China, but it's the same rocks. It's a little thicker in Syria than North America, but it's the same 6 rock layers. So there's a place where you can find all 6 of these megasequences, the whole record of the flood. Each chapter is there, all the way up to the receding phase in yellow. Secondly, every continent shows a progressive flood. This is the most important, I think, discovery of my career. Henry Morris talked about a flood, but he didn't know it was progressive. It didn't flood everything right away. It just flooded parts of the earth, parts of the continents. And then it flooded a little more, then a little bit more, then a lot more. And then it flooded over the top. And then we see evidence that it went down. So here's the way the flood works. The Sauk sequence. And then you pile on top of that Tippecanoe, pile on top of that the Kaskaskia. Then all of a sudden, boom, a lot more. And boom, the maximum. And then it all goes down. I have Australia done. I didn't have it done for this animation. Australia and New Zealand are done. They show the same thing. Every continent shows the same thing. Every continent shows the same order of fossils as well. You can see the same fossils in the same order. There really is a geologic column. The geologic column tells you it was global flood. Why do you see the same thing in the same order? Not always every rock in the same place, but overall the general order is the same. You know, what we think, these overthrusts put rocks out of order, but that's because they moved out of order. And they're evidence of these superfaults that can only happen quickly under high fluid pressures. And fourth, every continent peaks at about the same time. Every continent reaches the maximum coverage at about the same time. Here's the total of 6 continents. Here's how much of the sock was covered in the earth. This is by volume. See the first 3, there's almost nothing. They just cover North Africa, North Africa, North Africa. They just keep piling on top. These first 3 sequences were only flooding the shallow seas. Only limited areas across the middle part of Europe, across the Midwest here in the United States, where I grew up in Michigan, and across North Africa. The first 3 sequences stack right on top of each other. It doesn't cover the rest of Africa until, boom, the Absarica. See that middle one? 18.7% of the flood rocks all happen in the Absarica. That's where you see the first coal seams in great numbers all over the world. The Pennsylvania coals, the Carboniferous coals, they call them, all over Europe and North America at the same time. You see coal later, too. But that's where they first show up. Certain plants are deposited at that time. Different trees at that time than later. And then you see the maximum is the Zuni. Maximum amount, that's chapter 5 of the flood. So this includes the Cretaceous and Jurassic. The dinosaurs are wiped out, and right after that, that was the high point of the flood. Then the Tejas is the receding phase. These are all native tribes in North America named by a guy that was living in Wisconsin as a geologist. But this is the data. This is 6 continents worth of data. I can show you the surface coverage. The surface coverage looks identical. In the Sauk, the Tippecanoe, and Kaskaskia, it's a very limited surface coverage on the continents. And it's the same areas for the first 3, and then all of a sudden, boom, there's more. And then boom, there's a lot more. You see land animals show up in coal seams all at once in the Absarica. There's almost no land animals the first 3, because you're just flooding shallow seas. So I can even figure out and backtrack out the pre-flood environments of what was buried first and what those fossils are. You can determine the big picture of things, really how it all happened. It was a progressive flood, starting out small, built, and all of a sudden, boom. The Bible talks about the ark didn't float until after day 40 of the flood. So what were those humans thinking the first 40 days? It wasn't even flooding the land, just waves were washing in, burying animals in the shallow seas. They must have been going, this is not good. A lot of rain coming down too, this isn't good. But they really weren't being affected until the Absarica mega sequence, and suddenly the land started being buried. You start seeing plants being buried as coal seams and land animals being mixed in with the marine animals. There's marine mixing of land and marine throughout the rock record. Not early on, because it's just marine. You get T-Rexes with 6 species of sharks in Montana. And they also find lots of these rays, and you find coelacanths, those big fish they find in 500 feet down the Indian Ocean. They find those with Spinosaurus in Morocco. Well, the evolutionists say, well, those were freshwater fish back then. Those are all freshwater sharks. The data slaps them in the face like the tail of a fish, and they still don't want to believe it. They make up stories to justify their stories. And it just goes round and round. But they have the microphones, they can say what they want. So tonight's my night to say what the rocks really show. So what really happens here is this. The new hot crust comes up. When you make more ocean crust, it pushes things up from the bottom of the ocean and pushes the water higher. That's how the flood progressed from just a little bit to more and more. The more ocean crust you made, the more the bottom went up. And the more ocean crust, the more it started to hit the land. So all over the world, it hits the land at the same time. That's why the coal seams are all at the same time. That's why the land animals show up suddenly in great numbers at the same time. Because now the sea level is coming up. The bottom of your bathtub starts to rise. What's going to happen to the water? John Baumgartner's idea of runaway subduction rapid plate movement gives us the mechanism for the flood. More seafloor, more flooding. It took a while till you reach the peak. This is day 150. This is a picture of the Earth from space. The arc is there, you just can't see it. It's very small. It's only 450 feet long. But this is what the world would look like. Everything was gone. Humans might have lived down the Earth till 140, 150 days before they were wiped out. Can you imagine those last 10 days when you're trying to fight for the last little bit of land there was? How much fighting was going on when they realized there's nowhere to go? They tried to build little boats, but the boats were too small. The tsunami waves washed them over. Only the ark was big enough to survive. It's like God had a plan. He was going to save a remnant of the earth. Because he promised he would redeem the earth for the sin of Adam and Eve. And he needed some humans. So water went 15 cubits over the highest hills. That's why we don't see a lot of sediment in Canada, eh? That's why we don't see a lot of sediment across India or across Brazil. Those are the highest hills. You put them back together in the Pangea, you get this huge, massive high areas. All the rocks thin towards those hills. All the rocks are thin towards Canada. At least the Canadian Shield part, a little further east of here. They all thin to that. And then there's even some remnants up there. We'll talk about tomorrow in my talk. There's a little bit of remnants up there, like what I call the bathtub ring. How do you get rocks in the middle of nowhere? They had to come in from the sides. They had to be in there. So they only went 15 cubits, which is, if the water's only as high as this sanctuary, you can't leave thousands of feet of sediment. You might leave 5 feet of sediment, and that easily eroded away after the flood. But God had these waves zipping across 60 miles an hour, stripping it right down to the crust. He wiped humanity right off the face of the earth. There is no record I've seen anywhere of any human structures in the pre-flood world still in existence. He wiped humanity right off the earth. He didn't want us to know anything about those 1,600 years since Cain and Abel and Methuselah, and then boom, there's nothing. There's no history for 1,500 years or so because it was so wicked. That's all it tells us. That it was so wicked and so evil that God didn't even give us any record of it. There's nothing there. And he wiped them off the face of the earth, so we had to start over. And he spread the continents. And he spread humans around by the Tower of Babel, by lowering sea level for the Ice Age. He spread humans all over the different worlds so we wouldn't get in trouble right away. Humans are trying to disobey and stay at the Tower of Babel. God said, no, that ain't going to work. You're messing up my plan, so I have to spread you out by confounding your languages. And then you're going to get these land bridges so you can walk from Asia to North America just at the right time. Oh, look, there's the step. It's right there. They can just keep walking. You don't go into water. For a few hundred years, you had land bridges all over. That wasn't by an accident. That was by design. And eventually the water cooled as we go. As these ocean crust cooled and sank, it pulled the water back. And so today we have these very narrow ocean ridges. During the flood, they were really wide and high. Pushed the water up. And Andrew Snelling did some math and figured out you can push the bottom of the seafloor, can push the sea level 5,000 feet higher. And that might be all you needed because there were no Mount Everest until after the flood was receding. These big mountains didn't exist until the waters were receding. So there really was a global flood in an ark. You can trust your Bible. Where's the ark? Nobody knows. I told poor Dr. John Morris after he went up there 13 times, got hit by lightning, I said, I don't think it even landed on Mount Ararat. He was like, come on, Tim. I'm like, no, I think it landed somewhere 70 miles to the west on the mountains of Ararat, on this little mountain that came up just at the right time as the Zuni was peaking, the high point of the flood, because it landed on, it kind of ran aground on day 150 just as the water was peaking. And I think it was the Home Depot. After the flood, this is where the wood was. How many trees do you have in the next 40 years? You got the ark. God provided even for the people after the flood. They had instant building materials. They just dismantled the ark. That's what I think. That's why you're probably never going to find it. It's the Home Depot. It floated along. It was all part of the plan. But on a more serious note, the ark, that door of salvation, if you'd walk through that door of the ark, you were saved. But only 8 people did. 8 people believed there was going to be a global flood. If you ask people today how many people believe in a global flood, you'll get more than 8, but you won't get that many people. You'll probably get 1 in 10 maybe less than that. But that door was salvation. Jesus said, I am the door. By me, if any man enter in, he shall be saved and go in and out and find pasture. So Jesus opened that door of salvation for us. The ark of salvation for the people in the pre-flood world, but only 8 people believed. Today, Jesus opened it up for all of us by his shed blood. God has a plan for you. He has a plan for me. You might not know what the plan is, but he's got a plan. He's working it. God commendeth his love toward us, it says in Romans 5. In that while we were yet sinners, all of us are sinners, me, you, all of us. But even though we're sinners, Christ died for us. Much more than that. Being now justified by his blood, by his shed blood on the cross, we shall be saved from wrath through him. It's simple. You don't have to work your salvation out. Jesus did it all. He paid that heavy price of his own body. God himself came to earth. 100% God, 100% man. But that was the plan all along. From the moment Adam and Eve sinned, that was the plan all along. We see the ark as a type of salvation. But Jesus is the ultimate, eternal salvation for all of us. He's infinite forgiveness because he's an infinite God. His shed blood has opened the door for all of us. I hope all of you walk through that door and accept him as your Savior. We can be assured, folks, that the biblical worldview is true. I think I spelled assured wrong. There's supposed to be another R in that? Am I just getting tired? 2 hours out of whack? All right, superfaults and overthrusts confirm the special conditions of the flood. The only way you can get these thrust faults, these superfaults, like Heart Mountain Fault, South Fork Fault, and all the thrust belts all over the world, is by having special conditions set up by the flood. Rapid deposition of sediments, trapping some water in between layers, and a little bit of tilting, and off they go. And they still had to be soft. So they all had to happen quickly. Secondly, as I showed you a little bit here, and I'll talk more about tomorrow night if you come to CTAC, there is a compelling evidence for a global flood. Global geological data, the rocks cry out. I just feel privileged I was the one to be able to do this. ICR has allowed me to do this. Some of you that give to ICR, it's your donations to pay my salary so I can do this. I've still got to wrap a little bit around Antarctica. And then we're going to turn to where those sediments come from. That one's got my head straight. I don't know, that's going to be a tough one. But everybody asks me, where do the sediments come from? I don't know. So we're going to look into that next. So hopefully I'll get some answers. But this is what's there, and the rocks show that. So if you want to read more about that, I don't think I saw this in your back table. This is the book that I wrote that covers 3 continents where the data shows the patterns, which same thing for 6 continents. But this one came out in 2020, right? Like the week everything got shut down, you couldn't leave your house in March 2020. But it's been through a couple printings now. But this shows the story that I just told you about the flood anyway. It talks about the overthrust and the Heart Mountain Fault, shows some of those pictures. It's all in this book. So if you want to get that, you go to ICR.org. You can order that. We have a, speaking of COVID, we have a 5 CD trip across the American West, from Badlands to the Black Hills to Devil's Tower to the Grand Tetons and Yellowstone. We didn't quite get this far. We had to stop and go back, but I was really sick with COVID the whole time. I was like, walking, it was bad. And I got it from a guy that had both shots. 8 of us on a raft. We were rafting the river, and I flew up after the river up to continue on making this movie with some of my colleagues. And I saw the guy a year later. I said, no hard feelings. But God, literally, I was ready to go. I was praying. I'm like, God, if you have more plans for me, bring me through this. But I was this close. And my daughter was a nurse, and she was helping me. And it was awful. I wouldn't wish it on anybody, but God pulled me through by his grace. So he must have had some more plans for me. So I almost finished the world. But this was a great experience. We still go out there, do a lot of trips. It's a wonderful thing. My feet are AI'd in that picture. Those aren't my real feet. Because I think I was in some sort of grass and they had to do it. I don't know why, but it's kind of funny. You can get a digital download of that. It's cheaper to digital download. Some of you, what's a DVD player? Anybody know what a DVD player is? So some of you don't even have them anymore, but you can do digital downloads. And this is the book we wrote while we were all trapped in our apartments and houses during COVID lock-in. We rewrote this whole book, so it came out new at the end of 2020. If you don't have that, that book covers everything. Genetics, geology, dinosaurs, astronomy, all the evidence for a young Earth in a little very short nutshell. Very, very helpful if you're going to high school or college and you want to know there's another side to the story. So I got through college by remembering what Dwayne Gish told me. Don't say anything, he said. Just keep, read my books, read Henry Morris's books, and know there's another side to the story. Now I'm helping to write that story. It's been the greatest pleasure, the greatest job in my career. All the other things I did, I see God had a plan. He got me to the point where I'm at to do this work. And he's seen me through it for the most part to show you that God's word is true. And the best part about it is it points you to Jesus. It's all about Jesus. And now you can do this tonight, right? The rest of you got to order online. Benjamin, my handler, The events guy from ICR, he brought this with you. You can sign up for Acts and Facts, which are a free magazine. We've been giving it out since 1970, since ICR was founded by Henry Morris. It comes 8 times a year now, so I know some of you get it, but if you haven't, you can sign up in the back today, along with buying a bunch of books. So at this point, I guess I'll turn it over to questions. Is that correct? Heinz has got the plan, so. Thank you all very much for staying awake. It was kind of a sciencey talk, but we got through it.
Well, thank you. That was a lot of information you gave us there.
In a lot of short amount of time.
We'll take a few questions.
Isn't there a Creation Institute in San Diego? I know you're from Dallas, or?
It's the same one, but we moved.
Ah.
Yeah, like 2009, I think it was, before I joined them, they moved to Dallas. Henry Morris III said, "We're moving." And so off we went, and they left some people behind, unfortunately. But when you move, people don't want to move all the time. But we restarted in Dallas. So if you get to Dallas, we have a museum down there, a Discovery Center. It's pretty cool, $35 million museum. Got some really cool videos, and it's pretty impressive.
Okay, if you have a question, put up your hand. I'll bring the mic around.
You made a very interesting point about oil, crude oil, and it has to be young because of bacteria. Got me thinking, or rather, what do you think? What is the origin, and how did it get placed where it is?
Well, I think the geologists in the oil and gas business are correct that they can fingerprint the oil to the rocks that it came from. But what's coming from in those rocks is marine algae and plankton buried in the flood. So during the year of the flood, you were burying these rocks so quickly that the marine algae and plankton that normally dies and decomposes and doesn't get buried was trapped in those rocks. So you have these really good black shales that they're now fracking into. Theoretically, those rocks, like in West Texas, they're fracking in. The oil should have been generated 200 million years ago, so why is there still oil in there? Because it's not 200 million years old. And the evolutionary community says that, well, it was pasteurized at some point and just sitting there. And there's nothing that gets pasteurized and just sits there because the oil had to get there by groundwater flow. Groundwater is always moving down there. Any contamination is always moving. It's unfortunate because if you contaminate something over here, if groundwater is going that way, the contamination is going to go that way too. And that's the problem with a lot of companies. They contaminate their own land because years ago nobody cared. They just dump it out the back. Now we're finding all these contamination zones all over. The geologists are trying to clean up and pull out with wells and trying to figure out where it's going and what's down there. And so there's nothing that doesn't leak. And so no oil just sits down there waiting for geologists to tap into it. Just to me, but it's all mostly from marine algae and plankton buried in the flood years from the ocean. And that's been fingerprinted pretty well in geochemistry. And to me, it makes a lot of sense because you can't, those are fossils as well. You can't bury those without burying them fast and deep. All fossils have to be buried fast and deep because animals in the bottom of the ocean decompose. They don't make fossils today. And so fossils have to be special conditions of the flood. But there's an amazing amount of oil. And they've done studies that said if you just took 1 day's biota that's out there in the world, you get like 10 times the amount of carbon that's ever been found by oil in the world, in the history of the world. And so there's a tremendous, if you have a whole year to bury it, you've got a lot of organic debris. But most oil is partially decomposed, partially biodegraded, as we call it, or very thoroughly biodegraded. And there's oil seeps all over. The first oil seeps were at the Tower of Babel, and they were using that to make mortar for the Tower of Babel, ironically enough, within 100 or 200 years or so after the flood. One more thing on that, the pitch they put on the ark was not oil. That's the Hebrew word kofar, which means a covering, an expensive covering, sometimes referring to money. So whatever it was an expensive covering, just like Jesus' blood was an expensive covering for our sins. But he totally forgave them. He didn't just cover them. And so that's a totally different word than what's used at the Tower of Babel. So don't let the naysayers tell you, well, there was oil before the... No, there wasn't. There was probably just tree resins and things they cooked to seal it with that cost a lot of money. But the Hebrew words are different. So I've read some geologists from the state of Washington, an old earth geologist, David Montgomery, say, well, it can't be because he had oil before the flood because he put pitch on the ark. But he purposely didn't look into the Hebrew and see that that's a completely different word that probably was translated poorly as pitch. So I got off on a tangent.
Yeah, okay. A few questions popped up here.
The chapter on oil in my book, too.
What about the most recent talk about the amount of water that's been found under the surface at certain depths worldwide.
Well, they say that.
Anything to do with the flood, or is there any proof of that, or is it just talk?
That might be the source of some of the fountains of the deep, because there's still a lot of water down there that's, maybe triple, 4 times, 5 times, I've heard different numbers. There's water, it's not sloshing around, like oil doesn't slosh around either, it's in the rocks. And that water's in the mantle, in the upper mantle. And it's probably, that's why when magmas come up like at Mount St. Helens and they release a lot of water. Because it's like OH, it's not really sitting there as H2O down there. But once it comes out, it becomes water and CO2. Most gases given off volcanoes are 97% of the gases in water and CO2. So there's a lot of water coming out in the magmas today, and there's a lot of water down there. That could be the source of a lot of, the things might have been different early on. The fountains, we didn't really know what the fountains were. But I do see a lot of evidence of volcanic rocks, even before you start seeing flood rocks coming in. All these big strips up and down the east and west coast. And so there's a lot of evidence of volcanic activity that might have been the part of the initial part of the flood, and that might have released a lot of water from that area. So there's still a lot of water down there. It amazes me how people say Mars flooded. There's not a drop of water on Mars. Yet we've got 70% of the Earth covered with water that's 2.3 miles deep on the average, 70% of the Earth, and yet all that never flooded. It's like,
Okay, another
you can
question.
do the math.
Over here.
What, in your opinion, started the whole thing? What was the catalyst that kicked the flood into gear?
I think God did. I don't think you need an asteroid to come by and do anything. I don't think you need to use any natural process. I think God just said, today's the day. This is the moment. Boom, and he cracks all over the earth. And out came water and magma. And then that initiated the plates. We'll talk tomorrow. There's no other tectonic plates than any other planet in our solar system. Only Earth has tectonic plates. And so I think God, I just think, like any other miracle in the Bible, he had to start the flood by a miracle, and then it just played out like dominoes falling down. And he knew the conditions since he created it all. He knew exactly what happened. He even knew how the ice age would come along afterwards because of the flood. And I think he separated the continents to keep us from getting into trouble. Look what the internet does now. We can communicate too well, and it gets us into trouble. And that's what would have happened right away again if God didn't separate the continents.
God, I have a question now. You've published this work, at least in the Christian creation community. Have you published it outside in the secular?
Well, I published about the Heart Mountain Fault, how it moved fast, and South Fork Fault, how they move fast. And so I wrote a paper on that, but I haven't. I've given some talks at conferences, the Geological Society of America. I've talked about how the early flood events don't match the our sea level curve that we've been teaching our students for the last 50 years. There's no evidence of flooding early on because you see all these continents that are still high and dry. And they all went, that's interesting. So sometimes they allow me to talk and say things, but I can't say the flood.
Yeah.
But I can talk about the mega sequences.
Gotten any feedback from the uniformitary?
Well, they do kind of what they do to John Baumgartner. They say, well, we like your data, Tim, because the data is real. It's the real rocks that are there all over the world. But they don't like my interpretation. That's all they say. And I challenge them. How do you explain when you see the same thing happening on every continent at the same time, same order of rocks, the same pile of rocks, the same order of fossils? How do you explain that without a global effect, global event of some sort? And nobody says anything. They just either ignore me and figure he'll go away. And that's what they do to John Baumgartner. They know he's right. He didn't make any errors in his models, and they just ignore him, sadly. But you guys are willing to listen.
At what point in your life did you decide that God had the answer?
I'd say way back when I was 7 at Bible school when I accepted Jesus. But I didn't really know, what it all meant. But I knew that I needed, I knew I was a sinner, and so that kind of, but to get into geology, I think God gives you your desires of your heart that you follow because that's what that's kind of your plan. And so I followed geology. I never took a geology class in high school. I was taking chemistry and physics and all these college prep courses. Geology was for people that weren't going to college. And so I finally took a geology class in college, and I'm like, this is great, because it talks about history, and I loved history, and rocks, and you can make a living doing geology? Cool. And so it includes a little bit of chemistry, a little physics, a little history, a little paleontology. Who doesn't like to dig dinosaurs? We're going on dinosaur dig in August, ICR is over in Glendive, Montana, so if you want to go to that, I think there's still openings. But, what better job can you have? I got the best job, you guys, I'm sorry. But you got to follow, what God puts in your heart. And there's a reason for what you really like to do, I think, and that's part of the plan God has for you.
Do you think, as a Christian, you might have insight on are there oil fields that haven't been discovered?
Yeah, a little bit. I think I didn't get into this one. There's a whopper sand I talked about in the Gulf of Mexico that's really thick. They didn't think that was there. But I look at the rocks where I can see where the sediment's drained off the continents, like in the Bay of Bengal. I think there's a whopper sand out there. It's way out in 20,000 feet of water. There's one off the Niger Delta. They just haven't drilled far enough out there yet. And there's one off the Amazon River. They haven't drilled deep enough yet. But they're going to find some more of these whopper sands out there because that's where when the water first was going onto the continents and then it changed direction and came back. Tremendous amount of energy, like washing off a parking lot. Pushed all that sand out hundreds of miles off these areas. And those are the areas that are thickest today where you can see where it drained off. But they just haven't quite gone far enough out to hit those sands, which I believe are there. So in that regard, I think it might be helpful to have a little more open mind. Where other than that, most of finding oil is a game. You got to find the right structures and traps, like an upside down bowl. You have a reservoir that can hold oil, porous sand or something. You got to find a trap. You got to find the right conditions. And there's really no advantage being a creationist versus not for that. But for some of these big things, like what I think might be out there, from what I found, that might actually help. But they just make everything old because that's all they're taught. Most of these poor geology students that I went to school with, Christians, they just think everything's old because that's all they know. So they just don't talk about Genesis 1 to 11. They just think, go through my life reading the New Testament. But it's in 2 Peter. Jesus talks about the days of Noah. It's going to get more and more wicked before he comes. Noah was a real person who really lived and survived on the ark.
Yeah. I was just wondering, you live in Dallas. Have you been down to Glen Rose?
Yeah, a few times I've been down there with Carl, and we love Carl. We don't always necessarily accept that the dinosaurs and human footprints are real. I'm a little skeptical. I want to see a little better science before I start pushing that, because we want to make sure our science is verifiable as best we can. And at ICR, it says John Morris wrote a book, and I read it when I was in school. Greatest book ever, tracking those incredible dinosaurs and humans. And he wrote all this. They look like human footprints, and then 10 years later, he retracted it because those human footprints started to weather down further. He was just looking at this part of a dinosaur foot. And they started to see claws coming off those human footprints. So he realized those are not human footprints, those are dinosaur prints. So right now, the jury is still out. I'm not advocating that they're human dinosaur footprints. I think humans and dinosaurs lived in completely different areas based on my research. Humans were living in Canada, India, Brazil, these high ground, Scandinavia, areas stripped right down to the crust. And then they were spread all over. The humans didn't make fossils because they're the last thing buried, first thing eroded. And if you're not buried deep enough, you're not going to make much in the way of fossils either. And so the humanity was wicked to the core. That's why God doesn't even tell us about any of that. Can you imagine 1,600 years of history and there's nothing? You think about that, it's like, why?
Okay, let's have the Q&A.
Well, thank you all very much. What I say may not be correct all the time.
Well, thank you, Tim, for that presentation. Obviously, there's a lot of work going on out there to determine, the evidence for the flood, and it's very real. But getting the word out is the challenge, of course. So again, thank you for that. Next month, we have Dr. Keith Svensson from DSA down in Portland. So he's going to speak about another kind of a geologic topic here, as you see. Forests declare the glory of God. How do they do that? Well, he's going to explain that. There's a lot of forest even in this country, so he's going to cover the forests that go up and down the west coast, of course, and there's other forests in other parts of the U.S. and other parts of the world. He talk about what about them? What can we learn about God from them? So Keith is actually a retired medical doctor, and he's been a lecturer at Multnomah University there in Oregon for quite a few years. He was also the previous president of the Design Science Association in Portland, where they hold meetings like this as well. They do that on a Saturday morning of all times, but it works out very well for them. So he's got a degree in zoology and obviously a medical degree as well, and he's spoken on a number of topics here over the last number of years as well. So we look forward to having him there. I'll remind you there's a sign-up sheet for ICR, as you saw Tim had up here. Make sure you sign that so you can get on their mailing list of their publications. They have very good articles in there. Acts and Facts is one of the leading magazines out there from ICR. A lot of good stuff. And also for Apologetics Forum, there's a different sign-up sheet to the left of the table there. If you want to get our mailing list and find out who's coming next to speak and what's available from the Apologetics Forum as well. So there are some flyers left on the back table. They're all free for the taking. And again, look at there's one table dedicated to all the ICR books that we sell. And obviously there are more books, but we are selling these here today. And again, there's other books from other ministries on the Apologetics Forum table. So take advantage of that. And the way you sort this ministry again is through donations. And we thank you for donations, whether you make them here or make them online. There are 2 boxes at the back if you care to make a donation there. And you can always donate online if you're comfortable doing that as well. So, yeah, with that, I'm going to close in a word of prayer. It will be dismissed. There are refreshments to the left there. And, of course, you can peruse the book tables as well. Father, we thank you for this time. We thank you for Tim's ministry. We thank you for ICR's ministry and all the work that they have done with the scientists there. Lord, they're discovering truth of your word. They're showing the evidence of that truth. And we just thank you for Tim's presentation here. And we just pray that you would just continue to bless them. Bless each one here. Give them safe travel back home. And may they share what they've learned here with others that you put in their path. In Jesus' name we pray. Amen.